Dear friends, welcome to all of you in today exciting lecture. In today lecture, we are going to start the introduction of TensorFlow. We will learn why we use TensorFlow, why TensorFlow is so much important for deep learning, what are some basic concepts behind deep learning, how to install TensorFlow in your local system, in cloud environment. So we are going to get all this knowledge in today lesson. So by the end of this lecture, you will understand what is TensorFlow and why it is important for deep learning and machine learning. You will learn the basic component of TensorFlow. You will learn how to set up the environment for using TensorFlow. You will run your first TensorFlow program and perform some basic operation. So uh, let's start with the definition of the TensorFlow. What is TensorFlow? TensorFlow is an open source library and it is developed by Google by for machine learning and deep learning tasks. So TensorFlow is an open source library and it is developed by Google for machine learning and deep learning tasks. So this is first point, very important point which you should keep in mind. And the second point is it was developed for internal use by Google. Okay, Google team initially thought that they will use TensorFlow for their internal product, but later TensorFlow is used for building neural network and AI system. Now the question is why TensorFlow is so much important. Okay, what are the reason why TensorFlow is used in deep learning and training large model? So first reason is flexibility. TensorFlow support both low-level and high-level API, and it's allowed developer to build their model from scratch or let them use a predefined model. So by both way, you can use TensorFlow. Okay, you can build your model from scratch. Either you can use a pre-trained, pre-built model for classification and regression tasks. Okay, and the second reason why we use TensorFlow is due to its scalability. Okay, so TensorFlow is designed for scalability, allowing you to train large model in distributed computing environment. And the third reason is its vast community support. Its vast community support. So with TensorFlow active community, there is a wealth of tutorials, tools, and models availability. And there are some real world application of TensorFlow are also there. And those applications are Google Photo, Google Translate, and it's used in various industries like healthcare, finance, and robotics as well. So, what are ecosystem of the TensorFlow? So, if I will talk about the core TensorFlow, then it is the base library for building your model. And if I will talk about Keras works on top of TensorFlow. It is a high-level API for fast experimentation and model building. And other ecosystem is TensorFlow Lite. It is used for mobile and embedded device. And suppose you want to run your models in a browser, then what will you do? There is a ecosystem for that as well that is known as TensorFlow.js. It's related to JavaScript. And the last one is TensorFlow Extended. It is for production machine learning pipelines. Okay. Now we will compare TensorFlow with other framework. We'll compare TensorFlow with other framework. So first of all, we will compare with the PyTorch. So we can say that TensorFlow has a wide deployment tools, but PyTorch is favored in research for its dynamic computation graph. So PyTorch is favored by the researchers due to its dynamic computation graph nature. And there is some other library like Keras. So Keras was originally separated by TensorFlow, and now it's fully integrated with TensorFlow, and it is used as a high-level API. And the third one is Theano. It was the one of the earliest library, and now it is not widely used. So we can say there are two main library, TensorFlow and PyTorch for deep learning and neural network training. And Keras is integrated with TensorFlow now. Okay. So now the question is why TensorFlow remains popular? Due to its excellent deployment in production environment, and due to its scalability and versatility, and its strong Google-backed support and development, it's very much popular for our deep learning and neural network model training. Okay, now it's time to know how to set up our TensorFlow environment. So, if I will talk about the installation, how you will install it, so you can use PIP. So you can run a command like pip install TensorFlow, and as alternative, you can use Anaconda or set up a TensorFlow in Google Colab. So I will say that you should use Google Colab because it's hassle free. You don't need to run any command. You don't need to run any software for using TensorFlow in Google Colab environment. Okay. There are other environment option which you can use. So for local setup, you need to install TensorFlow on your local machine, and you have to ensure that Python 3.x or advanced version of Python or should be installed on your local machine. You can use Google Colab. It's a free cloud Jupyter notebook service with pre-installed TensorFlow. Okay, TensorFlow is pre-installed in Google Colab environment, and it's highly recommended for learner. And there are some cloud provider also which you provide the TensorFlow like AWS, GCP, and Microsoft Azure. I will talk about the GPU setup. So when you will log in your Google Colab environment, there will be option to connect with the GPU. But TensorFlow can leverage GPU for faster model training. Why to use GPU? GPU is used for the faster model training, and there are some compatibility of TensorFlow with the GPU as well. Okay, PyTorch and TensorFlow both are compatible with GPU to train their deep learning and neural network model. Now there we will learn about some basic concepts of the TensorFlow. Okay, so in TensorFlow you can see that TensorFlow is made from tensor and flow, and the part tensor is very much important. You should know about the tensor. So what is tensor? We are now going to discuss. So tensor is the core data structure in TensorFlow. What is tensor? Tensor is the core data structure in TensorFlow. And what are the property of TensorFlow? Tensor is multi-dimensional array similar to NumPy array. Okay, tensor is multi-dimensional array similar to NumPy array. Its example are scalar, vector, and matrix. If I will talk about scalar, then scalar has 0 dimension, and vector has 1 dimension, and matrix has 2 dimensions or more than 2 dimensions. Okay. Now, what are some computation graph which is used by TensorFlow? Which is used by TensorFlow. So TensorFlow build computation graphs. TensorFlow build computation graph where operation are nodes and edges are the tensor that flow between operations. So what is computation graph? TensorFlow builds computation graph where operations are nodes and edges are tensor that flow between operations. And these graphs are executed in session through TensorFlow 2.0 largely simplifies this eager execution. Now, what is eager execution? TensorFlow 2.x use eager execution by default, allowing you to run operation immediately without the need for separate graph building steps. Now we will see some hands-on example in TensorFlow operation. So for creating the constant, we can use tf.constant. For adding the tensors, we can use tf.add function. And for matrix multiplication, we can use tf.matrix multiplication function. And for variables, we can use tf.variable. We will do each and every hands-on in the next session. In this session, only we are introducing you about the TensorFlow basics. Okay. So now it's time to create the simple linear model. How we will create simple linear model using TensorFlow. So in regression we have used a simple line equation that is y equal to mx plus c. Okay, And we have used gradient descent for optimization, and we will use loss function and as mean square error, and we will use optimizer as stochastic gradient descent. Okay, so as a recap, we can say that TensorFlow is a powerful library for machine learning and deep learning. Core concepts include tensor, computation graphs, and eager education. We have also see hands-on example. We have demonstrate some basic operation and model building. Okay, so this is all for introduction for TensorFlow. See you soon in the next lecture with next exciting topic. Till then, keep exploring and keep learning machine learning and deep learning.